Alright guys, for 6.5, operations with radical expressions, buckle up for a little bit of a longer lesson. Only two objectives though. We're going to simplify radical expressions, and then we're going to add, subtract, multiply, and divide radical expressions. So here we go, let's do this. 6.5, the product property of radicals. So for any real numbers a and b, and any integer where that integer is greater than 1, okay, and that's talking about the power. If the power is greater than 1, then or I should say the nth root, right? The root is greater than 1. Then we can split it up and say that if we have the nth power of two things multiplied by each other, we can split it up and say, all right, well, that's the same thing as taking one piece of this, right, and multiplying it by the other piece of that power. So this comes in handy when you can do this, and the same is true in reverse, right? So if n is even and a and b are both non-negative, or if n is odd. Okay, so some examples. The square root of 2 times the square root of 8 gives me the square root of 16. Right? It's easier to evaluate the square root of 16 than it is these guys. These guys are not nice. Right? So there's a reason we'd want to multiply those together before we evaluate it. And then for the other one, the third root of 3 times the third root of 9 equals the third root of 27, or 3. Right? It gives me something nice here to evaluate. So that's just the product property of radicals. So let's use that here in example 1. Okay, so for example 1, what I'm trying to do here is I'm trying to get this into even powers, because this thing is taking the second root. If it's a square root, it's just the second root. So I want to rewrite this, and I want to write it in powers of 2 if I can, right? So I can break this 12 up into pieces. Know that if we have a square root of 12, that's the same thing as the square root of 4 times the square root of 3. Okay, since this is the second root, which is the square root, I want this into nice perfect squares. Okay, so the square root of 4 is actually 2, but I can't do anything with the root 3. So the big idea here for today, you guys, is we're going to take what can be simplified out of the radical, and anything that can't gets left behind in the radical. Okay, so for this one, we'll have a 2 on the outside because we took the square root of 4, it turned into a 2. Okay, and then I always leave a little space, and on the inside we have a 3. So I've taken care of the 12. Now for the c, if I take the square root of c to the 6th, we're taking 6 and dividing it by 2, this is equal to c to the 3rd, right? So I can bring that c to the 3rd out. Okay, and since we went from an even to an odd there, that's going to end up being an absolute value. But let's check our other thing before we do that. D to the 3rd can be, we can always take 2 powers out, right? So d to the 3rd is the same thing as d squared times d. So I can break that up into these two pieces. This one cancels, so it's the same thing as d root d. Okay, one gets canceled, the other, nothing cancels, so it gets left behind. Okay, so since I went from even to odd on the c, this would be an absolute value. Alright, and that's the answer. Let's go to 1b now and try this one. This is in third powers. Okay, so for third powers, I could divide by 3 or get things into groups of 3. So let's try this out. 27, the third root of 27 is 3. Okay, so I canceled that one out. Then let's keep our radical there with our third root. Y to the 12th. If you think about y to the 12th, I can get 4 groups of y to the thirds in there. So it's like y to the third, y to the third, y to the third, y to the third. Okay, and there's 4 of these groups. So if I cancel these out, I'm really looking for the groups there. Okay, so there's 4 groups, so that's y to the 4th, and that comes out. Okay, so I just took 12, divided it by 3, got my 4 that came out. Okay, and there's no y's left inside. No y's left. And then for z, if you think of z, okay, so here's another way to think of this. This is the same thing as z times z times z times z times z. These are z's, not 2's. Times z times z. Okay, if it's something to the third power, we're talking about taking groups of 3 away. So notice I can write this as z to the 6th, right? Because I can take 6 of them, those are groups of 3, times the square root of z. I should say the cubed root of z. So if the 3 and the 6 here cancel, and I'm left with on the outside z squared. And on the inside, I'm left with a z. Okay, so let me just write this a little bit better. This is 3y to the 4th z squared with third root of z. And I'm done. So what I'm trying to do is simplify this as best I can, taking all the third roots out. Here's the second root, here's the third root. When a perfect third root comes out, it stays out. If there's anything left over, it stays in. Now let's teach you another rule here, quotient property of radicals. So if I have the nth root of a fraction, I could just take the nth root of the numerator over the nth root of the denominator. Okay, where b cannot equal 0, because if b is 0, then we become undefined there. So some examples of this, we have this guy, right? The square root of 27 divided by the square root of 3 is the same thing as the square root of 9, which is 3. Right, so I can simplify this before I take the radical of it, or the root of it, I should say. So for this one, same deal here. I can rewrite this as the third root of x to the 6th, and then the third root of 8, and then simplify. Okay, so it's just a way of rewriting things, is all the quotient property is. And then the last thing before we do a bunch of examples here is rationalizing the denominator. So here's the big idea with this, you guys. You cannot have a radical in the denominator. So you have to get rid of any kind of radical sign. Okay, so the goal here is to get the denominator powers to be the same as the root. So what you'll notice is here on the example, you have 2 over root 3, right? We got to get rid of the root 3, so we multiply by root 3 over root 3. When you do this, root 3 times root 3 just gives you what's inside, 3. You can try that on your calculator. Okay, same deal here. We have 5 over the third root of 2, so we have to multiply this whole thing by the third root of 2. But notice 2 is to the first power here, right? So what I have to do there is I have to get the same exact power on the inside. So if it's the third root, I need 2 times 2 times 2. I need that base 3 times so that I can cancel it out. In other words, I need the third root of 2 to the third power for those to cancel out and be left with a 2. So what we do here is we increase this power from 1 to 2. Because when I multiply that out, okay, let me get some space here, because they didn't really show this very well, but when they multiply this out, when you multiply this group out here, you get the third root of 2 to the third, and then on top you have 5 times the third root of 2 to the second power, or 4. Okay, and then here, this cancels, so I can get rid of that radical. So I have 2 left in the denominator, and then 5 times the third root of 4 in the numerator. And don't try to take the square root of that, it's the third root of that, right? So you're done there. Alright, so let's try some of these. This is example 2. So here we go, guys. This is the square root of 8 to the 9th. Okay, so I'm going to rewrite this in terms of how I always think about this is if there's a square root, I just need an even exponent. So the biggest even exponent in 9 is 8. Okay, so that's like a to the 8th times a. And then here on the bottom, I'll do the same thing, the square root of b to the 4th times b. Okay, so I can rewrite it like this. The even ones will cancel out, right? So the square root of a to the 8th is a to the 4th, and that's on the outside. And then I'm left with an a on the inside. The square root of b to the fourth is b to the second power, and I'm left with a b on the inside. Okay, the problem with this is I cannot leave it like this. I've got to get rid of that square root of b in the denominator. So to do that, I'm going to multiply by square root of b over square root of b. Okay, so this equals a to the fourth square root of ab over b times square root of b times the square root of b is just b. B times b squared is b to the third. Okay, so there's the answer to 2a. 2b is a little bit more complicated, so pay close attention here. So this is the fifth root, right? So for this one, we have the fifth root of 3 over the fifth root of, well, okay, so here's where I'm going to show you this. We have 4 here, right? But 4 is not the principal root. Like there is a root, I shouldn't say principal root, but there is a perfect square that's in 4. 4 is not prime, right? So I can write 4 as 2 squared. And I'm going to do that. And there's a reason I'm going to do that. Okay, so I'll show you that. So this is 2 squared y. Okay, I have got to get rid of fifth powers here. So I need everything that's inside of this to be at a power of 5. To do that, I am going to multiply this thing by the fifth root of 2 to the third power, because if I have 2 squared and 2 to the third and I'm multiplying them together, I'm going to get 2 to the fifth, right? So I'm trying to get the 2 to be on a fifth power, and that's why I'm doing it 2 to the third. 2 to the third times 2 squared, when I multiply these out here, that's going to give me 2 to the fifth. That's my goal. Okay, and then for the y, that's in a fifth root, right? So I need the y to the fifth power as well, so I'm going to say times y to the fourth, because y times y to the fourth is y to the fifth. So I'll be left with, the goal is to get these things to the fifth power in here. Okay, so now I have that. When I multiply that out, right? But let's also do the same thing to the top. So 2 to the third, y to the fourth. Okay, so when I multiply that out, 2 to the third is actually just 8. 8 times 3 is 24. So I can write this as the fifth root of 24. 2 to the third is 8. 8 times 3 is 24. Y to the fourth. Okay. And then I'm not done yet because I gotta have to actually take these fifth roots now. So if I take those fifth roots, that's the whole goal of doing that. I get the fifth root of 24y to the fourth over 2y. And that is my answer. Okay, so that's 2b. Let's look at a summary here quick. So to simplify radicals, the index has to be as small as possible. Okay, so the n has to be as small as possible. The radical contains no factors other than 1 that are nth powers of an integer or polynomial. The radicand contains no fractions, and no radicals appear in the denominator. Okay, that's if it has to meet these 4 conditions before we can say that it's simplified. Okay, so here we go. Let's look at 3a. For 3a, we're going to multiply these things out. So let's just do that. So 6 times 4 gives me 24. And then let's take the square root here. 8 times 2 is 16. C to the third times c is c to the fourth. D to the fifth times d to the third is d to the eighth. Okay, so I just multiplied this out before I simplified this. Now what I'm going to do is I'm going to take these square roots here if I can. So the square root of 16 is 4, right? So I have 24 times the square root of 16, which is 4. Square root of c to the fourth is c squared. The square root of d to the eighth is d to the fourth. Notice I just cut those in half when I took the square roots. Okay, so 24 times 4 gives me 96. C squared d to the fourth. And I'm done. 3b, same deal here. So we have, this is the fourth root now though, so we have 6. 2 times 3 is 6. And then we're going to take the fourth root of 8 times 2, which is 16. X to the eighth. I'm just adding exponents here because I'm multiplying. Y squared times y squared is y to the fourth. Okay, so now we're taking fourth roots. Okay, so if you think about that, 2 times 2 times 2 times 2, 2 times 2 is 4, times 2 is 8, times 2 is 16. The fourth root of 16 is 2. So we have 6 times 2. And I took care of that one. If I take the fourth root of x to the 8th, I'm left with x squared. And I take the fourth root of y to the 4th, I'm left with y. So this is going to turn out to 12x squared y. And by the way, the y went from even to odd, therefore this has to be in absolutes. Don't forget about that guy, like I almost did. So adding and subtracting radical expressions. Remember that if you're adding or subtracting anything, you guys, you have to add and subtract like terms. Here, those are like radical expressions. So they have to have the exact same in on the outside, and it must be the same thing on the inside. So notice these guys are like. These are okay because the power on the outside, the in on the outside is just 2 for both of those. But here, notice, we have the same thing on the inside of the radical, but we have different roots. That is unlike terms. Those do not match. And then here we have a 2b on the inside and a 3b on the inside. It has to be the same thing on the inside. The radicand has to be the exact same, so these are unlike as well. All right, so let's look at some of these now. This is clearly unlike terms, right? But you need to simplify first and see if there's anything that is like afterward. So let's pull out any perfect squares that might be in here. Okay, so the square root of 8 is the same thing as the square root of 4 times the square root of 2. Okay, and then we have this plus 3 times the square root of, there's a perfect square in there, it's 25, so it's 25 times the square root of 2. Okay, so I'm rewriting those in perfect squares. The square root of 4 is 2. 2 times 4 is 8, so this is 8 root 2 plus 3 times the square root of 5 is this, square root of 25 is 3 times 5, which is 15 root 2. These are like terms. Okay, so I can add those together. When I add those together, I get 23 root 2. All right, that's for 4a. 4b, let's look at this one. So let's rewrite this in terms of perfect squares. This is 5 times the square root of 4 times the square root of 3 plus 2 times the square root of 9 times the square root of 3 minus, let's see, what would this one be? I think the square root of 64 times the square root of 2. Okay, so here I'm going to have 10 root 3. That simplifies. 2 times the square root of 9 is 2 times 3, which is 6. 6 root 3 minus, this would be 8 root 2. These can be simplified, so I have 16 root 3 minus 8 root 2, and I'm done. Can't do anything else with that. All right, for example 5. Okay, and then I think we're going to stop here. We need to split this up, I think. I will go into multiplying radicals and conjugates next time.